All right, let's dive right in. We're about to tackle one of the biggest, weirdest mysteries in all of science. Something so basic we almost never think to question it: time itself. I mean, we feel it, right? It's this constant river, always flowing forward. But what if? What if at the deepest level of reality, that's all just an illusion?
So let me just throw this out there. What if the entire story of the universe, from the very first moment of the Big Bang to its very last, is already written? What if it all exists at the same time, right now, and we're just experiencing it one moment at a time? It sounds like something straight out of science fiction, I know, but it's a very real idea that pops out of quantum physics. And to even start to get our heads around it, we have to accept that time seems to have a kind of split personality.
So to see how this is even possible, we first have to look at this huge conflict brewing in physics. It really seems like time is leading a double life. You've got the time we live and breathe every single day, and then you have this much, much stranger version that shows up when you start looking at the quantum world. On the one hand, you have what we call classical time. This is your everyday experience. It's like a straight road, right? It only goes in one direction, from the past, through the present, to the future. Cause always comes before effect. It's reliable, it's predictable. But quantum mechanics, well, it suggests something else entirely. Something way weirder. Quantum time is more like a tangled mess of paths, where the past and the future might both be influencing the present. Where time itself might not be a fundamental road at all, but something that just emerges from a deeper, stranger reality.
Okay, so where do we even begin to untangle all this? Well, our first big clue comes from one of the most famous and frankly bizarre things in all of quantum mechanics: entanglement. And this is where it gets really interesting, because entanglement seems to play by a completely different set of rules, almost as if it exists outside of time as we know it.
So what is it? In a nutshell, when two particles get entangled, they kind of stop being two separate things. They become a single system, and whatever happens to one of them instantly affects the other one. And I mean instantly. It doesn't matter if they're a millimeter apart or on opposite sides of the galaxy. It's like distance, and the time it should take to cross that distance just doesn't apply to them. They're connected in this timeless, distanceless way that just completely breaks the rules of classical physics.
But here's a distinction that is absolutely crucial for solving this whole mystery. You have to understand that not all entanglement is created equal. It can be a clean, stable connection that holds on to information, or it can be a messy process that leaks information all over the place.
Think of it like this. On one side, you have coherent entanglement. This is like a perfect secret hotline between two particles. It's a resource that preserves all that delicate quantum information. But then you have decoherent entanglement. This is what happens when a quantum system gets all tangled up with its noisy, messy surroundings. The air, light, anything. This process, called decoherence, it scrambles the quantum information. And this is key. It's what makes the classical world, with its one-way arrow of time, seem to emerge from the quantum chaos.
So we've got this idea of coherent entanglement being a perfect timeless link. Now, here comes the twist. What if that's not just some weird property of tiny particles? What if that's the very stuff that's holding the entire universe together?
This absolutely radical and honestly beautiful idea comes from the physicist Mark van Ramsdonk. He looked at all this and said, maybe the very fabric of space-time, the stage where all of reality happens, is actually woven together from these fundamental, coherent quantum connections.
Let's break that down for a second. The idea is that the more coherent entanglement there is between two regions of space, the closer they are. If you could somehow go in and cut those threads of entanglement, those two regions of space would literally pull apart from each other. So what does that mean? It means space-time isn't the fundamental backdrop of reality we always thought it was. Instead, it's an emergent property, built from a network of timeless quantum connections.
And this, of course, leads us to the most mind-bending idea of all. If space-time itself is built from something more fundamental, then what does that mean for time? This is where we run headfirst into a theory that literally erases time from the universe's master equation.
This whole line of thinking was pushed to its absolute limit back in the mid-20th century. A couple of physicists, John Archibald Wheeler and Bryce DeWitt, were trying to get gravity and quantum mechanics to play nicely together, and they decided to ask a truly radical question.
They just asked, what if we stop thinking of the universe as a box that contains quantum stuff, and instead,
We treat the entire universe itself as one single gigantic quantum object. What would that equation even look like?
And the result was the Wheeler-DeWitt equation. This was supposed to be it, the master equation for the whole cosmos. And when they finally wrote it down, they found something completely stunning. The variable for time, t, the thing that measures change, it was just gone. It wasn't there. According to this equation, the wave function of the universe doesn't evolve in time. It just is. Just as Wheeler himself put it, there is no before and after, only the whole. What he's saying is that at the most fundamental level of reality, there is no flow. There's just one single, static, timeless now that contains every possible moment that ever was or ever will be.
A really great way to think about this is to imagine the universe as a novel. If you hold the book in your hands, it's a static object, right? The beginning, the middle, the end, they all exist at the same time, right there between the covers. The story doesn't happen, it's just there, complete.
Okay, but that leaves us with a massive question. If the universe is a finished novel, why do we experience it as a story that unfolds, page by page? I mean, if reality is fundamentally timeless, where does our undeniable feeling of time's forward-moving arrow actually come from?
And the answer seems to be that time is a local story that we tell from inside the book. It's not a feature of the universe as a whole. It's something that emerges for observers like us who are stuck inside of it. We don't get to experience the timeless whole. We only get to experience the relationship between the parts around us.
So here's how it all seems to fit together. The universe as a whole exists in that timeless, static, coherent state. But inside that universe, little subsystems, like you, me, the planet, the galaxy, we all interact with each other. And this interaction causes that messy, decoherent entanglement we talked about before. Information leaks out, things get scrambled, and you get an irreversible process. And it's this very process of decoherence that creates the illusion of a forward arrow of time for anyone inside the system looking out. So to bring it back to our novel analogy, it means the universe really might be the static, completed book, but our consciousness, because it's bound by local physics, can only ever read it one page at a time. The flow of time that we feel is just the act of turning the pages of a story that was already complete from the very beginning. Which leaves us with one last pretty profound question. The past, present, and future might all exist at once, woven from a timeless fabric of quantum connections. And our journey through it all is just one possible reading of this grand cosmic story. So if we are the readers, what or who is the narrator?